Okay, so we are starting today with topic 5.4, magnetic fields. So what is a magnetic field, right? So the first thing we should introduce here is a question. What is a magnetic field? We have seen gravitational fields on previous unit, topic 6 I think it was, force per unit mass. We have talked about electric fields, force per unit charge, newtons per coulomb, newtons per kilogram. And now we are looking at a new concept that is called magnetic field. Let's use the letter B. Let's question, what is this? What is the definition? What are the units? So this is how we start our lesson. We're going to pause this lesson for, let's say, 20 minutes. I want you to watch this video, Chris Donner's video. I want you to have a look at it and then see if we could come back with a definition of what is magnetic field strength. Yeah, you probably won't find the definition, but you at least know what this topic is about, right? We're looking at what happens to charges when they move inside magnetic fields, right? So first of all, we need to know what a magnetic field is, what creates magnetic fields. So pause the video, watch this in the slides that I shared with you, watch this video from Chris Donner, and come back to me to understand the idea of a magnetic field, and then we'll continue. When we're looking at the interaction between magnets, we see these laws, right? Like poles repel and different poles attract. This is a law in magnetism, right? But you don't have to confuse poles with charges, right? Many times we get this confusion of electrostatics with magnetism, right? So the fields we have seen are these invisible lines around magnets where we have to draw the lines and assign a certain direction. So by convention, in the same way we assign the direction for the field lines in electricity and gravitation, here by convention we assume that the direction of these field lines is always from north to south, right? So in a magnet, we can see this pattern. If we put iron filings on top of a paper, we can all see these patterns, and we assign a direction, and by convention the direction is an arrow that goes from north to south. And very similar to a magnet are the lines around a coil, a solenoid, right? The interaction here of charges with space create these magnetic waves. We shall see this in some experiments and demonstrations, and we shall see what the direction of the field is relative to the current. All right, the syllabus in the IB says that you should be able to draw magnetic field lines around bar magnets and show the direction, and between bar magnets. So these lines you should be able to identify, right? And then the density of the lines is connected to the strength. So if the lines are closer to each other, so the lines, first of all, the direction goes from the north away towards the south, right? So that's by convention. And then where you have closer lines, you have stronger fields. Same thing we did for electric fields and gravitational fields. The separation between the lines is giving us an idea of the strength of that field. So you should be able to draw these, I mean, probably not all of them, but at least you should be able to draw this one and this one, this one. This is a bit more complex. But as long as you follow this convention that the lines go from north to south, you can always find ways of visualizing the patterns, right? So these visuals, if we zoom in, right, these visuals are important for you to ponder and look and observe for a while. You see these lines that go from the north towards the south, and they bend here because this is closer than this, and this ends up pushing in this direction, right? So this is part of the knowledge that you need to have in the syllabus. Moving further, what happens with the Earth? Interesting, the Earth acts like a magnet, and the first question is here, why? The North Pole of the Earth means that a compass is pointing towards that north, right? So the geographic north of the Earth corresponds to a magnetic south, right? And the geographic south corresponds to a magnetic north, because this is the way we accepted the convention of the current, so of the lines, right? So distinguish between the north pole of a magnet, sometimes known as the north seeking pole, and the north pole of Earth, yeah? So the north pole of Earth is the south magnetic. And understand that a compass is a needle that is just very small, a very small magnet. So what is a compass? So if you have a magnet and you hang it from a string, right? So this would be probably the north and this would be the south pole, and we could draw the lines there. Right? So these lines, these magnetic field lines, would align with the very weak magnetic field lines of the Earth. So the north will end up pointing to the north. The magnet will rotate until it points towards the north. This is something that has been discovered by the Chinese many thousands of years ago, but understood quite recently. Why is it that the Earth acts as a magnet? All right. So what are the next topics that we need to understand in the syllabus? Describe the shape and the spacing of magnetic field lines around a wire carrying a current. Right. So if you surround a wire with compass needles, you will see that the compass needles follow the shape of a circle around the wire, right? Wherever you place the needles point in these directions, right? So this is something that is giving us the idea of the direction of the field relative to the current also. And there is a rule for that, and the rule for that you need to understand. The direction of the magnetic field carrying a current and the relative direction of the field and the current is with the right hand. Right hand rule, the grip rule. Right hand or grip rule. This rule is it's not explaining why, it's just explaining how we could remember the relative direction of the current. So if the current is the direction of your thumb, yeah, then the field is going in the direction of the other fingers. And of course, as you move away from the wire, in this case, the current is going into the page. When you see a cross, it means that the current is going in, because it's like the back of an arrow, right? So if you point with your thumb into the page, your other fingers will point in these directions using the right hand, right? But it's also important to separate these lines more as you move away from the wire, because the field gets weaker. Same thing we saw with gravitational and electric fields. So, done, the grip rule, known. Let's move on to what happens when we have a current in a solenoid. Well, the solenoid behaves like a bar magnet. If we use the conventional direction of the current, that means if we use the current as assuming positive charge going into the coil, then using the same right-hand rule, we can see that the field lines that come out of the coil come out in this direction. So this would be the north pole of the coil or the electromagnet, and this would be the south pole. So outside of the electromagnet, the field lines go from north to south, and they separate further and further as you move away from the coil. But inside the coil, you see that the field lines get very, very, very close to each other. So that means that this becomes highly dense in terms of magnetic flux, right? And they go from south to north. So that is the difference between outside and inside. Inside, they get very compact and they move from south to north. Outside, they follow the convention of north to south. Yeah. So this is what happens in an electromagnet. In this case, in this case here, if you see the current is coming out from here, and it's coming in from here. So if you wrap with your right hand, if you wrap this coil with your fingers, the thumb would point in this direction. So that's giving you some applications of what we have learned that you will find on the OLP in the form of quizzes. So that's all for lesson 1. I hope you're able to go back and scroll back and draw these field lines. It's a very visual lesson. Understand these things. Just go back into this video, right? And just understand what's to come in the next lesson.